these are the solutions for the review for the final test, questions 81 to 101. So number 81 asks us to factor each polynomial. And so when we do that, I always look at the prime numbers, either the first or the last number. And I see that the last number is prime, so I'm going to start with that. 3 and 1 are the only numbers that make 3, and they both have to have addition signs in front because they multiply to make a positive and add to make a positive. So now I need to figure out what numbers multiply to make 6x squared. Well, I need to put it in a certain order so that the outside and the inside terms will add to make 11. And you see, if I do it this way, I have 2x here, and then I have 9x here. And 9x and 2x add to make 11x. So it does end up working out. So that is the factored form there. 2x plus 3 and a x, or a 3x plus the 1. And so moving on to the next problem here, again, we look for common factors. Always factor out that greatest common factor first. And I'm going to do that here. I'm going to divide every number by 2. So I'll put the 2 on the outside. It makes the factoring go a lot faster as well. So 2, and then I got 3x squared minus 2x minus an 8. So now I've got another prime number. This time it's the first number, 3x, and x make the 3x squared. Now numbers that multiply to make 8, you gotta just be careful, make sure you get it in the right order. I'm going to put the 4 here and the 2 here. This will make a 6x for the outside, inside make 4x. I can get those to subtract to make a negative if I make the 2 negative and the 4 positive. And that would be my answer. Over here, no common factors, so it factors as 2 binomials, and it's going to factor to a 2x minus a 5y and a 2x plus a 5y. So whenever you have a binomial that is a quadratic, you can factor it only if it's a difference of squares, and that's what we have here. So if the first and last term are both perfect squares, it factors that way. Next one, we have x squared. It has to be x and x. Numbers that multiply to make a positive 6y would be like a 6y and another 6y. You see the outside terms and the inside terms both make 6xy, which add to make the 12xy. So you could end up seeing it as x plus 6y quantity squared. That's another way to write that answer. Over here, there's a common factor. Not only does 3 go into each of those terms, but x does as well. So factor out the 3x, do the division. You got x squared plus 6x plus 5. And now that factors one more time. So if we go ahead and check out that trinomial, it factors to an x plus 5 and an x plus 1. And then make sure you keep that 3x on the outside as well. Over here, another difference of squares. Again, when you see the first and last term are both perfect squares, it factors to a sum and a difference, x minus y and x plus y. Those are the answers. Moving on to the next part, solve each quadratic polynomial. And so this time, we can use different methods. I'm going to try factoring on these problems. So I'm going to move this 5 back to the other side. So now I've got 2x squared plus 11x plus 5. And so when we go ahead and solve this, I go ahead and factor it as 2x and x make the 2x squared. Numbers that multiply to make 5 would be 5 and 1. So if I put the 5 here and the 1 here, it does end up working out. Now both signs need to be positive, so I'll put plus signs there. And when we go ahead and solve, so I know the factoring is done right because I check my outside inside terms. When I go ahead and solve, I've got 2x plus 1 equals 0. And I set the other one equal to 0 as well. X plus 5 equals 0. So when I go ahead and solve, I end up with a negative 1 over 2. See, I had to subtract the 1, then divide by the 2. So I got negative 1 over 2. Over here, I get negative 5 as the answer. Moving on to the next one, I move that 10 back to the other side. So I got 7x squared minus 3x minus a 10 all equals 0. And so when I go ahead and factor it, I'll factor it to 7x and x makes 7x squared. Numbers that multiply to make 10, I'll try a 2 here, and that would make 14. How about this? How about a 1 here and a 10 here? See, if I put the 1 times the 7 makes 7. And if I put a negative 10, that would make negative 10x. Positive 7, that would subtract to make the negative 3, so it would work. And so when I come up with the answers on this first one here, I got to add the 10, so it's positive 10, divide by 7, so 10/7. Over here, I just subtract the 1, I get negative 1. Well, the next one, again, move the 24 back, got 3x squared minus 14x minus 24 all equals 0. So when I go ahead and factor that, I'll start with the 3x and the x, multiply to make the 3x squared. Numbers that make 24, well, I got lots of choices. 6 and 4 do. And again, I'm trying to get them to subtract to make 14. So I also have 8 and 3. I've got 2 and 12. So I got lots of different options here. But when I do it, I'm trying to think of a number times by 3 to make something bigger than 14. When I think about it, if I try a 6 here and a 4 here, it should work out. See, the outside make 18. And if I make that negative, it would make a negative 18. Here, if I make this positive 4, those would subtract to make negative 14. So when I go ahead and solve this, set the 3x plus 4 equal to 0. I've got to subtract the 4 and then divide by 3, so negative 4/3. Over here, I just have to add the 6. That's how I get that answer. Here it's already set equal to 0, so we'll start with the 5x and the x. That's why we like prime numbers, because we can just put them down. We don't have to think too hard about what they would be. Both plus signs, though, because they multiply to make a positive, add to make a positive. To make it a 6, I'm going to try 6 and 1 like this, because you see the outside make 30, inside make 1. Those would add to make 31. Well, to solve, you're going to set the factors equal to 0, and you have to subtract the 1, so that's why it's negative 1. Divide by 5, you get negative 1/5. The other one, just negative 6. That is our answer. Over here, you've got to move the 6 back, so we've got 5x squared plus a 7x minus 6 all equals 0. And so when we go ahead and factor, I'll start with the 5x and the x. Numbers that multiply to make 6, let's try a 2 here and a 3 here. Those will multiply to make 10, the 5x and the 2. To make it a positive, I'll make it a plus sign for the 2. Make the 3 negative, and that would give us a subtraction of 7 when I do the outside-inside terms. To solve, I have to add the 3, divide by 5, I get 3/5. And then to subtract the 2 on the other one. Taking a look at the next one here, I've got a difference of squares, so it factors to x minus 2 and an x plus 2. Set the factors equal to 0, you get 2 and negative 2. Well, the next part is asking us to solve by completing the squares. Remember, you're going to always take half the b term, take half the 8, and that gives me 4. But then I have to square that number, and I get 16. And that's the number you add to both sides. So once you add 16, you end up with an x minus 4 quantity squared. And this all equals 9 and 16 make 25. So when you take the square root of both sides, you now have x minus 4 equals plus or minus 5. And then from there, you just have to add the 4 to all sides. And you add the 4 to 5, and that's how we get 9. Add the 4 to negative 5, and that's how we get negative 1. Over here it's a little bit trickier because we have to take half of a odd number, and we have to deal with a fraction. So we have 5 halves, but we have to square that number, and that's where we're getting 25/4. And that's the number that you add to both sides. So 25/4 here plus a 25/4 over on this side. And so when I do that work, I end up with a x plus, and then whatever half our b term was, so 5 halves, quantity squared, and then I need to add the 25/4 to the 7. So I need to multiply 7 by 4, and so that gives me 28/4 plus the 25/4, which ends up giving me a grand total of, looks like 53/4. And so when I go ahead and take the square root of both sides, it'll cancel out the squared symbol, leaving me with this x plus 5 halves, but it equals plus or minus the square root of 53 all over 2. And so all you have to do is subtract that 5 halves, and you get this negative 5 plus or minus the square root of 53 all over 2. And that would be my answer. Over on this side, again, you're going to take half the b term, so that is 3, and square it, and that makes 9. So I end up having to add 9 to all sides. And then I go ahead and factor this. X plus 3 quantity squared equals 19. Take the square root of both sides. Leaves me with this x plus 3 equals plus or minus the square root of 19. Subtract the 3, and you get negative 3 plus or minus the square root of 19 is the answer. Next one, we want to solve this, so we're going to end up subtracting the c from both sides, and then we'll divide by a. So here's what we get. X squared plus b over ax equals negative c over a. So I subtracted the c divided by a. I take half the b term and then square that, and that goes inside the parentheses eventually once I factor it. And so now I've got x squared plus b over ax, half the b terms b over 2a, square that, I end up with a b squared over 4a squared, and that's what I end up having to add to both sides. So negative c over a plus b squared over 4a squared. Well, I need to come up with that common denominator and add these two fractions together. And so when I do that, on this side I can factor it. I get this x plus b over 2a, quantity squared. Here I have to multiply this by 4a over 4a. And so when I do that, I get this b squared minus 4ac all over 4a squared. And so from that point, all I have to do is take the square root of both sides. And when I do that, the squared symbol cancels out. I'm left with x plus b over 2a equals, and then plus or minus the square root of the b squared minus 4ac all over the 2a. Square root of 4 is 2, square root of a squared is a. All you have to do is subtract this b over 2a from both sides. Denominators are the same, so you can write out that quadratic formula. Negative b plus or minus the square root of b squared minus 4ac all over 2a. And that is the solution there. Let's take a look at some other problems here. Here we're solving by the quadratic formula. So we're just taking our a, b, and c values and putting them into that equation. So it's the opposite of b, so negative 3 plus or minus the square root of 3 squared. So that makes 9 minus 4 times by 2 times by negative 7 all over 2 times by 2. So to do some work there, we have negative 3 plus or minus the square root of 9, and it becomes a plus sign because of the two negatives here. So that makes 56 all over 4. So we go ahead and do a little bit more work. Add those numbers together. Negative 3 plus or minus the square root of 65 all over 4 is our answer there. Over here we start with our negative 3, but take the opposite. So it's 3 plus or minus. And then negative 3 squared is 9 minus 4 times by 4 times by 1. And then it's all over 2 times by 4. Well, when we do the work here, we get 3 plus or minus the square root of 9 minus 16 all over 8. Well, 9 minus 16 gives me a negative number underneath the radical side, and that's the problem. Can't have that negative number there, so this is a no solution. Look at our next one. We have to start with the negative 6 plus or minus the square root of 36 minus 4 times 5 times negative 2 all over 2 times by 5. So negative 6 plus or minus the square root of 36. And then this can be a plus. Plus 20 and 2 make 40 all over 10. So do some work there. Negative 6 plus or minus the square root of 76 all over 10. And that is our answer. And the next one here, we'll start with by subtracting this 3 from both sides. So now I've got 6x squared minus 2x minus 3. So when we substitute in, we've got the 2 plus or minus the square root of 4 minus 6, or minus the 4, times by 6 times by negative 3 all over 2 times 6. So 2 plus or minus the square root of 4 plus, that makes 24 times by 3 gives me 72 all over 12. So 2 plus or minus the square root of 76 all over 12 for that one. This one, again, same thing. Always move the terms to one side when we're using the quadratic formula, then substitute. This is a negative 1, because the b term's 1, plus or minus the square root of 1 squared minus 4 times by 2 times by negative 4, all over 2 times by 2. We do that work there underneath the radical sign, and remember to add the two negatives, make a positive, and then we get to add those two numbers underneath the radical sign. So negative 1 plus or minus the square root of 33 all over 4 is the answer. Well, those are problems from that assignment. Check out other videos for other problems.